Good morning, students. I believe you are ready for this class. Your level of seriousness should show by picking a pen and a paper, even your jotter, even your textbooks as well. So, I believe you are set for this class. Please, put away all distractions in whatsoever. Put off all TVs. Don't be distracted. Just focus. Now, this morning I'll be taking you through simultaneous linear equations, which will be 2. My name remains the same, Mr. Ilesanmitokbe. Please do well to follow through. I believe you enjoyed the first class, which was on Monday, and I know that you are set for today. And I believe all assignments has been done. And I believe all questions has been forwarded to the mail on the screen. Do well to ask questions and do well to solve questions. Solve exercises as well. In our last class, we discussed about linear equations, simultaneous linear equations, and we talked about the method of solving simultaneous linear equation. And we discussed that the elimination and substitution method, they are the algebraic method of solving, of which we represent the unknown with variables. And mind you, we discussed about what linear equations of two variables is. That is an equation with two unknowns. So, I believe you are set for this class. We talked about the first method, which was substitution method of solving simultaneous linear equation. So this morning we are going to continue from where we stopped, and which will be method 2, which is elimination method. So I think you are set for this class. Please be set. Okay. Now, the lesson objectives. The lesson objectives is the same thing as the ones that we have in lesson 1. That is, after this class, you must be able to understand simultaneous linear equations in two variables. You must be able to identify linear equations with two variables. You must be able to solve problems on simultaneous linear equations using the two methods. We've discussed about method 1 in the first class. That was on Monday. Now, we're discussing about method 2 in details. Method of elimination. That is what we'll be looking at this morning. This is the lesson 2. Now, they said this is an algebraic process of solving. Mind you, take note. Algebraic. I think someone is out there wondering what's the meaning of algebraic. Algebraic means the use of letters. Letters. We use letters to represent unknown. Okay, let me give you an example. Say, I think of a number. When I added 2, the result is 10. What is that number? Mathematically speaking, when you want to start, you said, let the number be x. X simply means algebra. That is, you use letter to represent unknown. That's what we mean by algebraic process. Using letters to represent unknown, to represent what you don't know, what you are looking for. In mathematics, we are always looking for x and y. And bet me, we will always be. Because that is the beauty of mathematics. Okay? They said this is an algebraic process of solving simultaneous linear equations with two variables. Note the word. With two variables. Not with several variables. Several variables is not for your level. We are only considering in two variables. Variables can be A, B, C, D, E, F, unknowns. So, and I said further that it is very faster and easier than the substitution method. With examples, you are going to see the beauty of this. That this method of elimination is very, very easier and faster than the former method that we did. Now, let me make this thing clear. I want to point out something. When you are asked to solve the following pairs of simultaneous linear equations, when the method to be used is not stated, you can use any method of your choice. I repeat myself again. When the method of solving is not stated by your teacher, you can use any method, be it graphical, be it algebraic, which is the elimination and the substitution method. But if it is otherwise stated, follow what is stated. Okay? Now, there are steps to take in using elimination method to solve simultaneous linear equations. Just as we did in the first class, we have steps for solving substitution method. So we also have methods also for elimination. First method, let's go. Method 1 says, step 1 says, identify the coefficients of the unknowns. Why do we need to identify the coefficients of the unknowns? We are going to see that in the course of this lesson. And I told you earlier on that mathematics is better learned by practice. You can understand mathematics better when you solve questions, when you solve examples. Now, the next point says multiply the coefficients of the unknowns by the factors. Okay? Just take notes. The next step is the coefficients of the unknowns must be the same. Must be the same means the numbers attached to the coefficients of the unknowns must be the same. So, if I'm talking about the same or sameness, sameness does not mean if it is plus 6, it must be plus 6. The two unknowns. Sorry, the unknowns. If I'm saying plus 6x, then plus 6s. No, that's not what I'm saying. The coefficient must be the same. 6, 6. That is, the coefficient is what is attached to the unknown. Now, the final step is you can eliminate either by adding or subtracting. This is where students find it mostly difficult. And bet me, it's not difficult. Okay, let's continue. Now, let's have our example 1. I believe you are there, ready with your pen, paper, your jotter, your writing materials, and everything. Now, we want to solve the equations. 3x plus 2y equals 12. That's first equation. 5x minus 3y equals 1. Now, what I taught you in our last class was you will write out the equation and label them accordingly. 3x plus 2y equals 12. We call this equation 1. Then 5x minus 3y equals 1. We call this equation 2. So there are some things that are not on the step. I mean, they are not part of the statement of the step, but we are going to apply it. That is why you need to listen very well to what the teacher is saying and avoid every distractions. Now, so that you will not be confused, always look out for the simplest. I say it's always look out for the simplest. Now, the method of elimination is that we want to eliminate either x or y from the two equations. We don't want to see them. And we now have our resulting x alone. I don't know, maybe you understand what I'm trying to point out here. Your aim is to eliminate x from the two equations. Or you want to eliminate y from the two equations. But the coefficients of the unknowns are very important. And what you do to one, you must do it to all. What do I mean by that? If you are multiplying 2, for instance, to equation 1, you are going to have 6x plus 4y equals what? 24. That is, the 2 must multiply the whole equation. Everything, every time. Okay? Now, I want to eliminate y. And someone will ask me why. The reason is that I found something here. Y is attached with addition sign and subtraction sign. So if I should do something, if I should multiply this by a factor, this by another factor, and I add the resulting this thing together, is going to eliminate y. That will make sense. But in another case, if you are having positive sign here, both positive, and you want to do something, it's either you multiply negative of the factor that you want to multiply on equation 1 or equation 2. Either of the two. At least you must have a negative such that when you add together, it will give you 0 and it will eliminate either of the unknowns. Okay? Now follow me. I want to eliminate y, as I've said earlier on. This is 2, this is 3. What will I multiply to this equation that will make this one, this and this to be the same? So that I'll be able to eliminate y. What is that factor that we are looking for? That once we multiply it by this and with this, it will give us the same thing. That is 2 and 3. That is, either you multiply this one by 3, that is just the only way. You multiply this one by 3, and multiply this one by 2. 2 times 3 will give you what? 6. Then 3 times 2 will give you what? 6. That's what we are looking for. Okay? I'm multiplying equation 1. I'm doing it directly. This one by 3. That's equation 1. Then this one by 2. Now, what will now be our resulting equation? Now, equation 1 is by 3. So that will be 9x, because 3 multiplied by 3 will give you 9, plus 6y equals 36. This is equation 2. This is equation 3. Now we have by 2 here. This will be 10x minus 6y equals 2. This is equation 4. How are you seeing it? So interesting. Okay. Now, this is plus 6y, then minus 6y. So you can add. Okay, and once you do that, 9x plus 10x will give us what? 19x. Then plus 6y minus 6y. That will be what? Plus 0 equals 36 plus 2 will give us 38. So, and this will give us 19s equals 38. So since you are looking for x, divide both sides by 19, and this will give us x equals 2. Now, you can use either of equation 1 and 2. Please don't go and make mistake. Don't go and use equation 3 and 4. You can use either of equation 1 and 2 to solve for y when x equals 2. Sorry. So, okay, let me use this side. To solve for y when x equals 2, that will be 3. So anywhere you see your x, you put 2 plus 2y equals 12. This is from equation 1. So you can use equation 2. I'll give you that as a trial. You can make use of equation 2. Then again, I'll give you this as another trial again. Try to eliminate x and let's see the resulting stuff. 2y equals 12. So when you collect the like terms, that means 2y equals 6, which is y equals 3. So this is continuation here. Please, after this side, you have this side. Okay. This is another question again as well. And this is quite different from the first one that we had. We want to use the method of elimination to solve this equation. 3f equals 4 minus 4e. 2e equals 5f plus 15. Now, what we are going to do first in this case is that firstly collect the like terms. Okay, let me say pack the ones that are having the unknowns to one side. Are you getting me? Okay, what I mean by that is that 3f, now this is minus 4e, going to that side, that will be plus 4e equals 4. This is equation 1. Then I'm going to have the second one, which is minus 5f, because once this one crosses that bridge, that will be minus 5f plus 2e equals 15. So whenever you have any problem like this, you must firstly do this thing. So by packing all the unknowns to one side and the ones that is a constant, take it to the same size also as well. Now, are you seeing something? This is positive. This is negative. Positive, positive. This. Now, if I want to eliminate, I will not eliminate e. You can eliminate e, fine. But if you want to eliminate e, that means it's either you multiply this one by negative factor, this one by positive factor, or you multiply this one by negative factor and this one by positive factor. But I want to eliminate f. This is positive, this is negative. I can just multiply my factors to change it so that I can eliminate. Are you getting me? Okay. Now, this is 3, this is 5. So I can multiply this one by 5 and this one by 3. So I'm multiplying equation 1 by 5 and equation 2 by 3. So if I do that, that will be 15f plus 20e equals 20. Please don't forget to label this equation 3 in your notes. Then this is minus 15f, then plus 6e, right, equals 45. So I can add this and this will give you 0, because when you add that will give you 0. Then 20e plus 6 will give you plus 26e equals 20 plus, that will give you 65. Okay, let me check again. This is 20. This is 20. This is 15. 6. This is 45. Correct, okay? Now you have 26e equals 65. Okay? So that will be 26e. This is 0 equals 65. So you divide both sides by 26 by 26. You get your E to be. Okay, let's look at this. 13, that will be 5. 13 here 5. 13 here 2. That is 5 over 2. That will be your E. I use 13 to divide. 13 here 5. That should be 5 now. That is 15, 1, 65, okay, 2. That's 5 over 2. Now, to solve for f now, when E equals 5 over 2. So, I'm using equation 1. That will be 3f plus 4, so into 5 over 2 equals 4. This is 4, this is 2, so you can cancel. This is 2, so this should be 3f plus 10 equals 4. Right? So if you collect the like terms, that means 3f. This will be 4 minus 10. 4 minus 10, which will give you minus 6. Since you are looking for f, you divide both sides by 3 by 3. So your f will be minus 2. Do you understand now? From here, 3f over 3, dividing both sides by 3. That will give you f equals minus 2. Okay? Any question? Okay, let's continue. Oh, sorry. Okay, example, continue. Sorry, this space, you are supposed to use it for example 1. Oh, sorry. Okay. Now from 1, yes, from 1 you have that x equals 2 and y equals 3. Place from 1, from example 1, from example 1, x equals 2, y equals 3. Okay, let's check. Okay. For example 2, from example 2, e equals 5/2 and f equals -2. Okay, I'm sorry for that. I'm sorry. Okay, we have to note this. Note that this method can be very useful when the first value found is a fraction, since fractions often give difficult working when substituted. What this point is saying is that whenever you are working with substitution method and you have a fraction, it is always difficult. But when you are working with elimination method, you don't have a fraction. So that is the meaning. Now, look at those exercises. Use the method of elimination to solve the following pairs of simultaneous equations. So, try to lay hands on them. Use elimination, not substitution. Thank you very much for listening. God bless you and stay safe.